This video is about RIS nomenclature for stereoisomers. There are four basic steps to name stereoisomers. The first step is to assign priority to groups on the stereocenter, followed by assigning RNS based on that priority. You then follow it with the usual method to name the compound. And the last step is to indicate RRS for each stereocenter at the beginning of the name. If you have more than one stereocenter, then you will indicate positions such as 2R, 3S, followed by the name. Our first task is to see how to assign priorities. For each carbon stereocenter, we're going to assign priorities 1, 2, 3, and 4 to all the atoms that are directly bonded to that stereocenter in order of decreasing atomic number. That is, the atom with the highest atomic number receives the highest priority, and 1 is the highest priority. So if we were to take this example of this bromochloroidomethane, we can say this is a hydrogen. Remember that hydrogen has the lowest possible atomic number, so this is always going to be assigned a priority of 4. And then if we look at the iodine, bromine, chlorine, if you think of the periodic table, iodine has the highest atomic number, so this is going to be 1, followed by bromine, 2, and chlorine, 3. So the highest priority goes to iodine because it has the highest atomic number. Now what if we have two atoms in the stereocenter that are the same? Now let's look at this example. We're looking at this stereocenter here, and it's easy to assign the hydrogen. That's going to be the lowest priority, so that's 4. And it's easy to assign the bromine because when you compare the bromine, hydrogen, and these two carbons, bromine's got the highest atomic number, so it's going to be the highest priority. Now we need to compare these two carbons. Let's first draw out all the atoms that are bonded to carbons A and carbon B. Carbon A has 3 hydrogens, and carbon B has 2 hydrogens and another carbon that's bonded to it. So if we compare it, we're looking for the first atom of higher priority number. So we look at B. B has got a carbon, hydrogen, hydrogen, and A has got a hydrogen, hydrogen, hydrogen. If we look here, this is a higher priority than this hydrogen, which means that B is going to be a higher priority than A. And so B is going to be assigned a group priority of 2, and carbon A is going to be assigned a group priority of 3. So far we've assigned priority based on atomic number. However, isotopes have the same atomic number. So now we're going to look at the mass number, and we assign priority in order of decreasing mass number. So if we consider the 3 isotopes of hydrogen, we've got hydrogen, which has a mass number of 1, deuterium has a mass number of 2, tritium has a mass number of 3. That means that since tritium has the highest mass number, we're going to assign tritium a priority of 1, followed by deuterium and hydrogen. For atoms that are in a multiple bond, we are going to treat the multiply bonded atom as an equivalent number of singly bonded atoms. Let's look at an example for this. In this first example, we're trying to assign the stereocenter here, and we can say that the bromine is going to be the highest atomic number, so it's 1, hydrogen is 4. Now we have 2 carbons, and now we have to assign it based on the atoms bonded to these carbons. So let's label it carbons A and carbons B. Carbon A has an oxygen, a hydrogen, and a hydrogen. Carbon B is tricky because now it has a double bond to an oxygen. This fourth rule is saying that when we have atoms that are in a multiple bond, we're going to treat the multiply bonded atom as an equivalent number of singly bonded atoms. So we will translate this into 2 carbon-oxygen single bonds. So if I were to redraw that, I'm going to consider it is a structure like this. And in this case, we can complete our comparison. B is bonded to an oxygen, oxygen, hydrogen. Now if we compare A and B, the first atom is oxygen, oxygen, those are the same. And when we compare the second atom, we find that B has oxygen as opposed to A, which has hydrogen. Oxygen has higher atomic number, so B is going to receive priority. So when we assign B and A, B is going to be a priority of 2, A is going to be a priority of 3. Likewise, we can consider triple bonds. In this molecule, we don't have a stereocenter, so we're not assigning priorities. But to think about how this would look, we would translate it to this structure where these 2 pi bonds are going to be 2 bonds to carbons, and likewise here. Again, there's no stereocenter in this molecule, but this is what a triple bond would look like. Now let's actually try naming a compound. The first thing we do when we try to name a compound is to assign priorities from 1 to 4, with 1 being the highest to each group that's bonded to the stereocenter. So for this stereocenter, we've got a hydrogen, and we know that's going to be a priority of 4. Iodine is going to be 1, bromine 2, and chlorine 3. The second thing we do is orient the molecule so that the lowest priority group, 4, is in the back. That means that we're going to be looking down the carbon-hydrogen bond. And the easiest thing to do is to draw a Newman projection. So when I draw this Newman projection, I'm looking down the carbon-hydrogen bond, which means that the carbon is in front, and that's the carbon that's the stereocenter, and the hydrogen is directly behind. And so that means that the bromine is on the right, the chlorine is on the bottom, and the iodine is on the left. The next step is to trace a circle from priority group 1 to 2 to 3. And if the circle goes clockwise, it's the R enantiomer. If it goes counterclockwise, it's the S enantiomer. And we know that iodine was 1, bromine was 2, chlorine was 3. So when we trace the circle 1 to 2 and 2 to 3, we are going in the clockwise direction. If it's clockwise, it's the R enantiomer. And so we can name the compound. And the compound name without any stereochemistry is bromo-chloro-iodomethane. And we know that we were going clockwise, and so it's the R enantiomer. So you put a hyphen and R in parentheses in the front. The R is going to be italicized.